Hello my fans, and welcome to my video today. I want to show you how to derive the first principle of differentiation. And if not the first time we come, hit the like button now and hit the subscribe button because many things you will see for this particular channel in Pidgin English. But if you be returning subscriber, you don't come before. Thank you very much. I will hit the like button. Make you run now. Don't forget to share. The first thing we're going to do now, I want to show you what you will see everywhere. If you find the first principle, what will be the formula for the first principle of differentiation? You always see everybody they say the y over the x equal to, you could even see them say limit as the x tends to 0 of function of x plus h. Maybe I use the x here because I don't already start. The x minus function of x as divided by x dx. You will see this kind of thing for plenty places. Some people will say, no, I want to use the x. Anywhere I see the x, I want to use h. So we just say the y over the x equal to limit as h tends to 0 of function of x plus h minus function of x over h. If you see them like this, or if you see them like this, my fans, these two things are the same thing. Anyway, we want to choose, use them. But my interest now to show you how they derive this one. If I show you how to derive and finish, you know, say another video now to show you how to use and solve problem. And if I say you no gonna like them and you no gonna share them, it means you no want make I show you how to use and solve problem. Because I won't break and down in Pidgin English. Now as the matter they be now, I go lie for you. Oh yeah, now as you don't understand it like this, I make we clean them and see how I want to take. Copy and down or make you know what they do because copy and down, don't tell you. Copy and down because I want to show you how I want to derive this thing now. But I will make them very simple. The first thing, I derive in different ways. But make I just show you using this Cartesian coordinate. Just like when you plot your graph now, you know, say yeah now your y-axis, yeah, the x-axis. I need to remind you for that one already. You know already now. So let's say if now y my x-axis on this Cartesian plane, now I want just consider 2 points. Before you get to point, let's say this graph now a straight line graph, where maybe from the point of origin, or maybe from, it might not be this point of origin, it might be somewhere, any particular point like that, and a straight line graph basically, like the graph E. I feel use other curvy kind of this thing and locate 2 points. But yeah, if I decide straight line graph and say maybe I get 2 points like this on this particular plane, XY plane, what's going to happen? The next thing I'm going to think of now to find the slope. You know, see if you won't find slope now, and from this point you will do this like this and come with this particular one. Maybe so. If you can't do this kind of stuff, you know, so since here on a y-axis, if you do this here and say, yeah, okay, make here be my y1 now, and then this particular point now, make here be my y2. Yeah, go be my x1, and here go be my x2. You never finish on my fans. So with this kind of information like this now, I know say x to change from x1 to x2. That means I will call them change in x. For y to change from y1 to y2, I'll call them change in y. You know, say yeah, at the horizontal. I mean, horizontal we call it the vertical, they call them jaw. See vertical, then the vertical, horizontal, then the horizontal. So it means say if you want to take the slope now, slope, where you know say then they use m as a symbol of slope, you would say okay, slope now will be the change in this y as a result to the change in this particular x. That means it is likely they tell us say m now will be equal to this the y over the x means y2 minus y1. That's the change in y. The change in y2 minus y1 over x2 minus x1. You get the point now. So you did like talk say as the value of y they increase. Now so it lead to the increment in the value of x. So if I bring another one from this particular point, it means say as y they even increase go y3, and so x go increase. I don't know if I'm shouting. You understand what I try to tell you? So now I will get like 3 coordinates for this particular place. At the first be this, the second be this, the third. From here, since y1 and x1 they lap for this point, I will say this point now for x1 comma y1. Let me this point. This point now at the point where y1 and x2 lap. So I've said this point now x2 comma y1. I will use all this information. Let me show you. This particular point now at the point, if you check now, the point where this x2 and y2 lap. You dey see this thing for text, we don't know wetin dem be. I dey show you so. And I dey use Pidgin dey break am down. If you like share this video, like am abeg. So now, remember na derivation wey my interest dey. I no dey show you how to use and solve. Now the next video I will show you how to solve. Now, wetin be the next thing you want to do? Remember, say for maths, we don't agree. All the mathematicians don't go meeting, agree, say y na equal to f of x. Why? Because others, some mathematics go say y equal to some functions like that, maybe 3x cubed minus 4x squared minus 5x plus 2. Some others say y equal to function of x now. Instead of function, they will say maybe 2x minus 5. They will just say y equal to, they declare different functions. Now this guy, the way they call Euler. Euler come, see his name. Euler, a great mathematician, come say, instead of everybody go dey get y equal to different functions, what we dey try to say, make we just use the general formula we will use, general expression, like general formula we go make things easier. Maybe y equal to f of x. So if you see y, now the same thing as f of x, f of x, you still replace it with y. So this is trying to say, if you take some input, say x, any input, any number, if you take input, if you can't introduce any input for here, make we see the behavior of y, how y go behave anytime we put any kind of input. All those one they get, anytime we put inside x, make we see how y they behave. So make we use one to generalize that. E enter B. Now, since we don't agree like this now, remember say we don't get y2, y1, x minus this. So in place of this particular function now, see what I want to do now. Now what I want to carry derive. I think I go use different method derive. So if I can't get this in place of this one now, I get here, we get y1. Y1 will become function of x1. Remember, say y now equal to f of x. So if I get y1, it will be function of x f1, f of x1. If I get y2, it will be function of x2. No be so. Talk now, no be so. Now so. Now this thing will take, they introduce these ones, these two I get, and only two I get now. And here for this particular one, remember say now dx, I'll show you here. Slope m now dy over dx. Maybe y2 minus y1 over x2 minus x1. So you don't agree, say dx now the same thing as x2 minus x1. You don't agree on that one, Abi? If maybe they say make you make x1 the subject of formula, or say make you make x2 the subject of formula, you know how you take do am now. They like to talk, say make minus x cross come here to equal plus x. x2 will come remain. x2 will come equal to x1, we cross come here, plus this the x. That's what they do now. All these things what I get, I will use them right now. How I want to take use them? Oh yeah, make we start. So I know what they use this slope again, m, this symbol. Make we just use this dy over the x. So dy over the x, maybe the slope now will be equal to, what will be y2? Y2 there now, y2 now f of x2. y2 now f of x2. I don't record that one, keep. Minus, maybe this minus. What will be y1? y1 na f of x1. I don't record that one, keep. All over, what will be dx? dx na x2 minus x1. So that means any place where I see x2, this x2 minus x1, I feel replace it with this dx. Remember, say we want to derive the first principle of differentiation, the first principle of differentiation, we want to derive. So now, if you get this point, you see, say I get x2 here. x2 here, now this guy. You see I'm so? So that means in place of this x2, I go replace this x1 plus dx for this particular place. So that means I can come out this part. Make I get space, carry do my work. I don't know whether if I write here, you go see I'm. So I can't get the y over the x equal to function of x2. Now waiting, x2 now x1 plus the x minus f of x1 over the x. Remember some book now, instead of them to use the x here, they use h for all this place. Now be the first principle. So, but if you want to make the answer they more accurate, you can say from this particular graph now, if this particular dx now on the 4 from this top now on the 4, you go 4 till you go come back to the point of 0. So we go say if you want make a demo accurate, they go say the y over the x, the y over the x now will equal to limit, you can introduce limit now, as that thing I tell you now, as the x go tend to 0, like go tend to 0, go approach 0. That means the direction when you come, they come approach 0 for you to get more accuracy for this one. Will be the function of this x1 plus, if you no use this x1, oh, and same thing as x, dx minus f of x over dx. This thing wey you see so, na be the first principle of differentiation. Na be the first principle of differentiation. With this first principle of differentiation, if we even derive the general formula of differentiation, where you always see as the y over the x equal to nx to the power of n minus 1. This general form of differentiation, if you use the same first principle, carry derive any formula we dey see inside differentiation. You understand? It's very, very simple. It's as simple as ABC. But my interest here not to derive this one, which we don't achieve. If you know, say the derivation makes sense to you and you don't learn from the derivation, but you know say you could just help me hit the like button first. Secondly, you could drop the comments to encourage me, say he enter. Then finally, you go share and make other students like you follow learn from this one, because they don't know say I don't do this video. You need share and make them know about them. And if I see you don't like them, then you go motivate me. I'll be in the solve problem under this first one. I don't go lie for you now. I don't go lie for you. So when I need an instructor, Alison, I mean they teach math and science for Pidgin English. The reason because I won't break these things down for the language where only you if you understand. So now all I get from you for you today, make sure say you like this video and hit the subscribe button so that anytime if you hit subscribe button and finish, you don't go do anything. If you turn on that bell icon anytime we I post video, now you go first see them. But like for you, me, I don't come out to peace and love.